Hey everybody, we're back this time to talk about when stars blow up, where does all that shit go? And also what comprises us. We have a couple rugrats running around, so if they come in and out of the video, please excuse. So first, our disclaimer. These are solely Levi's thoughts, opinions, etc. based on nothing but sources he has attained on his own free will. And we plan to avoid hot political topics and rather just kind of focus on the hows and whats in general. So here we go. Levi, talk to us about what happens when stars explode up there.
Okay, so I'll back up a little bit and we'll start with where the stuff you're made of comes from. And again, I know there are different beliefs in the world on where stuff comes from, so I'm not going to go down that avenue. I'm going to stay on the
You're
avenue.
a scientist, we understand.
I'm going to stay on the avenue of things we know and see and can prove mathematically, and we know we can see it.
The tangibles.
The tangibles. It happens all around us. So, if you were to go way, way back, yeah, basically your fundamental element in the universe is hydrogen. It's one proton. It's huge clouds of it. Nothing else. Gravity, which we talked about in the last episode, which I don't think a lot of people like, but
the theory of relativity. In case you missed
gravity naturally starts bringing things together. Okay, it holds you to the earth. So when that happens, you basically, if you get enough hydrogen, it starts to all that weight crushes in on itself, and you get fusion, which is of course the sun, right? So the sun runs on nuclear fusion. What I don't think a lot of people don't realize is during that process, it makes all the elements that make you and I. It makes carbon, it makes oxygen. All comes from stars. It's all made in the same spot. What happens is you've got two hydrogens, and through immense pressures they fuse. Okay, well when they fusion, you create helium. So you go from hydrogen to helium. One, now you have two. And anybody who's familiar with fundamentals of chemistry knows every time you add a proton, you change elements.
So which we are not. This is layman's terms.
So this is layman terms. So you start with one, and you can go all the way up to like uranium and plutonium, which are like 138. The more protons you add, the bigger the molecule gets, the heavier it gets, right? Each one of those has different characteristics, which is why some are solid, some are liquid, some you breathe, some you eat, right?
Question. Is uranium from Uranus?
No.
Oh.
It is not.
Well, that's odd.
Funny. Huh. So anyway, what happens over time is when those fuse, when those two protons fuse, there's a huge release of energy. Well, when you look at a star, it's basically a balance. So I read something in an article, I don't remember the exact numbers. But
Scientific American.
Yeah, I can't remember. But it was something like our sun alone, like every 1 second, fuses like 620 metric tons of hydrogen, and it fuses it into like 605 metric tons of helium. And you think the weight shouldn't go anywhere, right? If you had 620 before, you should have 620 after.
Right.
But you can't, because what happens is that difference is actually what's released off as energy. So, and that energy is something like 500 million atomic bombs going off every second. So that's why the sun is hot, right? What's happening is the sun's trying to explode. So you have this outward pressure from all this fusion, but then you have gravity kind of crunching it all together. And that's why you have this balanced sphere of just molten plasma that over years makes all the elements. What happens is it goes, 1 to 2, 2 to 4, 4 to 6, 8, and you start fusing these things together. And every time you do that, you make a new element. Right up until you get to iron. When you get to iron, which is the difference between iron is everything up until that point is what's called an exothermic reaction. It means it gives off energy, right? So that's the atomic bombs going off. Mm. When you get to iron, it's what's called endothermic. It actually consumes energy. So if you think about that balance that's being played, you have this outward pressure and this inward pressure. Well, if you take away that outward pressure, all you have left is the inward pressure of gravity, right? So the star basically collapses on itself.
Oh.
So the bigger the star, you start to get things that are called supernova, right? And if they go really, really big, you'll get what's left over as a black hole, which of course is back to the last topic I talked about, the theory of relativity. So anyway, what happens is, as that star is fusing, it's making oxygen, carbon, all the things that make us us, right up until the point that it gets to iron. When it gets to iron, at that point, the star's dead. It's going to die. It took them a long time to figure this out, but what happens is it immediately crushes in on itself. And they've been running the math, and for a long time they couldn't get the star to explode, right? Because there's a bounce of energy. It hits the core and it bounces. And it took them a long time to figure it out. And I actually saw this the other day on TV, and it just totally made sense. So if you think about that fusion process, you've got all these different elements in this star, and they'll actually layer themselves in a star. If you think about, you have oil and vinegar. And some of your seasonings, you see those layers in there. Okay, those layers are due to the densities and the differences between the components of the vinegar dressing, right? So the same thing happens in a star. You have layers, and if you think about, if you take like a large, use this, My Little Pony ball. This is, let's say this is oxygen. If you try to crush oxygen and get it to bounce, it doesn't bounce enough. And if you were to take something smaller, say helium, and try to get bounce, it doesn't bounce enough. And what somebody figured out is if you layer them, like we think happens in a star, the heavier on the bottom and the lighter on top, and you bounce it, the little ball
you almost
shoots
knocked
off.
over my
Almost
wine.
knocked your wine. What happens is you get this huge compression, and all that energy is stored
Interesting.
and it releases. What's really cool, and most people don't know this, is all your gold, your platinums, all the things that are heavier than iron, they come from basically giant supernova that explode, and that last crunch of pressure is enough energy to make some of these. That's why we call them rare earth metals, is because they're rare. They don't happen in fusion. They happen during a supernova. So it's pretty cool when you think about it. All the gold in your ring or in your necklace or in your ear or whatever, in your tooth if you're older, that all actually came from supernova explosion that, millions and billions of years ago was blown out into space. And over time, our sun settled into a cloud. That cloud basically congregated, came in on itself, made a sun, and then our planet spinning around that formed the Earth, and inside of that cloud was these metals. And they are rare. They're very, very rare for obvious reasons, because they don't happen in abundance like other elements. So if you think about it, when the Earth was made, whatever it was, 4.5 billion years ago, in that mix were all your golds and your platinums. So next time you look at your ring, it came from a supernova explosion. It's pretty cool.
That is very cool. I have never heard anything like that, actually. That's, yeah, very cool.
Makes you see things differently.
Yeah, so, and it's funny though, because, you can go out and you can buy gold anywhere. You can buy silver anywhere. You can buy platinum anywhere. So we say that it's a rare metal, which apparently it is, but it doesn't really feel that way when you can go out and buy it anywhere. And granted, it's not cheap necessarily.
I read a stat that somewhere, if you were to took the entire gold in all of the reserves around the world, you could basically fill one Olympic-sized pool. So while you say it's in abundance, there's not that much actually gold on the Earth that we know of. Now, what we found is in the asteroid belt between Mars and Jupiter, there is a lot. And there's a lot of asteroids out there.
I want to move there.
There's they think there's honestly trillions of dollars of gold in those asteroids. They can see it. They can see where it's at. They know where it's at. So a lot of these space exploration guys are actually trying to put missions together on how you could go to a satellite, mine gold, and bring it back. But that's another topic.
Yeah. Okay. Well, maybe next time we'll have to find out where diamonds come from, so all these
Can't answer that.
women can, jump on that. All right. Thanks, Levi. This is Layman's Terms with Levi. We appreciate comments. Bye.